Okay, we're going to talk about linear functions some more. And a linear function or a linear equation is simply an equation whose graph is a straight line. And the simplest one, or what we call parent function, is just that y would equal x. So if I were to graph that, let me just go ahead and use straighter lines here. I'm going to graph that. It's going to look like that. Okay. Everything else for a linear equation is a function or just a variation of that basic equation. All right, and if I can add a constant to it, so y equals x plus maybe 2. Okay. Let me change that to, so if that's in red, and if that's 2, not sure why I went to that. Okay. I'm going to have, it just moves it up 2. If I change it so that I say that I can multiply the x times a number, oops, take that off, x, I wish it would do what I wanted to do, thank you. All right, 2 times x plus 2, okay, go back to the line. Then it's going to cross in the same place, but it's going to be twice as steep. Okay? So anything you start with this basic equation, being silly, and we can multiply or add or subtract or divide, and it'll change the direction and or shape of the line, but it's still basically just a straight line. It is also a function because I'm only intersecting the graph of the line from the x-axis. Each x value only has one y value. Okay, so take those off, back to black. All right, so that's linear equations. And in the book, it says it will ask you to find solutions for an equation. And really, I'm going to change the terminology. Instead of saying finding solutions, I'm going to say evaluate. And I'll tell you why here in a second, but what I mean is that, so you can do a quick little table, x, y, and so for an example, if I have y equals 3x plus 1, I want values for my x. I plug in x into my equation. I come up with a value for y, so this would be 1, this would be 4, this would be -2, this would be 7. All right. I want the word evaluate because later on we will talk about solutions, and solutions will be defined as values for x that make y equal to 0. Okay? Very specific definition. So I don't like the fact that they changed that. Okay. Related to that, we have the terms y-intercept and x-intercept. Okay, and in each case it is what it means where the line of the graph intercepts that particular axis. So this is where the graph crosses the y-axis. And this is where the graph crosses the x-axis. All right, and in this case, we find that by saying that x equals 0, and we find the value for y. Here, we say that y equals 0, and we find the value for x. So let me give a couple quick examples here. Go back to blue. So if I have y equals 4x minus 2, I put in 0 for x, and I get that y is equal to -2. That is my y-intercept. Okay, if I have an equation that says that y equals 2x minus 4, so now I put in a 0 for the y. So I say 0 equals 2x minus 4. And I want to go ahead and solve that for x now. So that means that I have 4 equals 2x, or that x is 2. Okay? So that's my x-intercept. Y-intercept up here, x-intercept down here. Okay. All right, and that leads us to finally, on Monday, talked about this being my standard equation. All right, y equals mx plus b. This m is the slope of the line. This b is the y-intercept. Because when I put in 0 for x, and slope times 0 is 0, I'm just left with y equals the value of the y-intercept, or b. Okay, so that should be enough to get us going on problems, and I'll see you in class.